In this lesson, we're going to look at, again, an example 3 cos x minus 2 sin x in the form k cos x minus alpha. But this is slightly different in terms of the coefficients, and I'll show you why in a second. So, starting off point, use the addition formula to multiply out the brackets again. So cos, cos, sin, sin. The takeaway goes to a plus when you're using cos. So k cos x cos alpha plus sin x sin alpha. We're then going to multiply through again by the k, but we're going to take the cos alpha to the front and the sin alpha to the front to give this. So let's look at the coefficients now. So firstly, we'll look at k cos alpha. And if we look up here, this is the value in front of cos x. If you look up here, that's a 3. So we can quite happily write 3 here and rearrange it to get cos alpha, which is 3 over k, if we divide by k. If we now turn our attention to k sin alpha, part in front of the sin x. But if you look up here, there's a 2, but there's a negative here, or a takeaway. So in order for this to work, you need to really make that negative 2. So that would be 3 cos x take away 2 sin x if that was negative 2. And that's what we have to put here, negative 2. Divide through by k, so you get negative 2 over k, and then fill out your right angle triangle again. So we've got alpha here, and if we think about our trig work, or SOHCAHTOA, you've got cos is equal to adjacent over hypotenuse. So if you think of that on the right angle triangle, adjacent is going to be 3, so that's the bottom, and hypotenuse is k, which we've got here. And then sin alpha, that's your opposite side, and that's your hypotenuse. Sin equals opposite over hypotenuse. So the opposite side is going to be negative 2, and you always find the opposite side diagonally opposite the angle. Again, Pythagoras, the square root of negative 2 squared plus 3 squared will get you k. So that's going to be 9 plus negative 2 squared, which is 4, so root 13 by Pythagoras' theorem. Okay, let's move on to the second part of the question. We've worked out the amplitude of the new wave. We now have to work out the angle here, the shift for the cosine wave. So I'll take that information down below again. So I'm not doing anything new here, I'm just taking this information and rewriting it down here. I'm then going to try and work out what quadrant my new angle is going to be in. So I'll look at the cos, and cos is positive 3 over positive k, so that's positive. So I'll tick where the cosine is positive, and that's A and C. I'm then going to look at sine, and sine's negative. So I have to tick where the sine wave is negative. Now, sine wave is positive there, and it's positive there, so it's T and C. So this shift happens in the fourth quadrant. So we need to work out our base angle. So we've got tan of alpha is negative 2 over 3. If we work out our base angle or relative acute angle, you inverse tan the positive value there, so it's inverse tan 2/3, and that comes out to 33.7. But our alpha is in the fourth quadrant here. So we have to take that away from 360 for the fourth quadrant answer, and you get 326.3. So to finish it off, we've said k is root 13 and alpha is 326.3, so write that in the places that are relevant.